Welcome to Daily Papers, the podcast where we break down fascinating new research. Today, we're looking at a paper that asks a really important question about artificial intelligence. Is it actually smart, or is it just a really good actor?
Right. To get us started, here's a little puzzle for you. Imagine a car's odometer reads 15951. That number is a palindrome, meaning it reads the same forwards and backwards. Now, here's the question. What is the very next number that will be shown on the odometer?
Okay, the next number. Well, that seems easy. It would just be 15952, right? One more than 15951?
Exactly. Any school kid would say 15952, but when researchers gave this simple question to some of the most powerful large language models, or LLMs, the AIs that power tools like ChatGPT and Gemini, they got it wrong.
Wait, how did they get it wrong?
They confidently answered 16061 because they weren't answering the question that was asked. They were answering a much more common classic brain teaser. What is the next palindrome that will appear on the odometer?
They just assumed that's what the user meant.
Precisely. And that little slip-up is the key to today's paper. It's called phantom recall, when familiar puzzles fool smart models. The researchers wanted to systematically test how often this happens. Do these incredibly advanced AIs actually reason through problems, or are they just recalling memorized answers from their training data?
So how do you even test for that?
With a very clever method. The team gathered 25 well-known logic puzzles and riddles. These are the kinds of brain teasers you might find all over the internet, which means the AIs have almost certainly seen them and their solutions many, many times.
Okay, so the AIs should get them all right.
And they do. They get near-perfect scores on the original puzzles. But here's the twist. For each puzzle, the researchers created several perturbed versions.
Perturbed? What does that mean?
It just means they slightly changed the puzzle. Just like in our odometer example. They changed a number, a small detail, or the final question. The core logic needed to solve it was the same, but the final answer would be different. This forces the AI to actually read the details and reason from scratch, rather than just pulling up a memorized answer.
I see. So what happened when the AIs were given these slightly modified puzzles?
Their performance completely collapsed. They went from near perfect to getting things wrong a significant amount of the time. And this revealed a failure mode that the researchers named phantom recall.
Phantom recall is the perfect name for it. The AI is recalling a solution, but it's a phantom. It belongs to a different puzzle, the one it remembers, not the one it's actually facing.
It's like a student who memorized the entire answer key for a practice exam. If you just change the numbers in the questions on the real test, they'll still write down the old answers from the key because they never learned the method.
That's a great analogy. And what makes it even trickier is that the LLMs are so convincing. They don't just give the wrong answer. They often write out a long, detailed, step-by-step explanation that sounds incredibly logical and confident, but it's all just a justification for the wrong memorized answer. The paper calls this over-elaboration. So they're not just wrong, they're confidently and eloquently wrong. Which points to a bigger issue, right? They are excellent pattern matchers, but maybe not such great critical thinkers.
Exactly. The study suggests that there's a big gap between linguistic fluency, the ability to produce human-like text, and actual logical understanding. The AI can talk the talk, but it struggles to walk the walk when faced with something new, even if it's just a tiny change.
So, is this a fatal flaw? Did the researchers find any way to fix it?
They did try. They developed a special prompting strategy. A prompt is just the set of instructions that you give to an AI. Instead of just giving it the puzzle, they added a bunch of strict rules.
Like what?
Things like, do not use external knowledge or memorized solutions, or do not make assumptions about missing information. They essentially forced it to slow down, read the problem carefully, and only use the information given. They even made it break down its reasoning step by step and verify its work at the end.
Basically, they caught it the same good habits a teacher would teach a student. And did it work?
It did help. Accuracy on the modified puzzles improved quite a bit. But, and this is a big but, it didn't completely solve the problem. Even with these careful instructions, the AIs were still much worse on the new puzzles than humans are, and the phantom recall issue still popped up.
So the underlying fragility is still there.
It is. The paper concludes that while AI models can remember reasoning, they often fail to re-reason when the context changes. They're getting better and better, but this study is a fantastic reminder that the way they think is fundamentally different from how we do.
The big takeaway seems to be that we can't always take an AI's confident answer at face value, especially when it comes to logic and reasoning. They might just be recalling a phantom from their memory.
Exactly. And by creating this benchmark of tricky modified puzzles, the researchers have given us a powerful tool to measure and hopefully build AIs that are not just fluent, but truly logical.